सब्सक्राइब कीजिए ईएसए क्लासेस चैनल को और बेल आइकन दबाइए हमारे लेटेस्ट वीडियो सबसे पहले देखने के लिए।
Motion in one dimension. First concept is position or position vector. Position vector shows position of object. Then rest and motion. Change of position. If position is changing, then object is in motion. If position is constant, position is same with respect to time, then object is at rest. Same object can be in motion or can be at rest with respect to different observers. If a man is sitting inside car, then and if car is moving with velocity v, there is a man in the car and there is another man outside the car, and car is moving with velocity v. Then for the man who is inside car is stationary, car is at rest. But for the observer who is outside car is moving with velocity v. So rest and motion are a relative concept. Rest and motion are a relative concept. Then motion in one dimension means only one coordinate changes. Motion in two dimension means only two coordinate changes. Projectile motion and circular motion are motion in two dimensions. If x, y, z all three coordinates are changing, then motion is in three dimensions. Distance and displacement. Distance is the actual length of the path. And displacement is the linear distance between final point and initial point. If an object completes semicircle, and if radius of semicircle is r, then distance covered by object is 2 pi r. That is the actual length of the path, but the displacement is 2r. Displacement is the final position and initial position, linear distance between them. Okay, if object goes like this from point A to point C, then distance is AB plus BC. Whereas displacement is AC. Then speed and velocity. Speed is distance upon time, velocity is displacement upon time. Average speed is what? Average speed is total distance upon total time. Average velocity is total displacement upon total time. Then speed is always greater than or equal to velocity. Instantaneous speed and instantaneous velocity, they have same magnitude. Derivative of displacement with respect to time is instantaneous velocity. Acceleration is velocity change upon time. Average acceleration is total velocity change upon time. Instantaneous acceleration is dv upon dt, derivative of velocity with respect to time. Equations of kinematics. V is equal to U plus AT, S is equal to UT plus half AT square, V square is equal to U square plus 2AS, and Sn, this is the new equation. Sn, distance covered in nth second, is equal to U plus A by 2 into 2n minus 1. What is it? U plus A by 2 into 2n minus 1. N is the number of second. N is the nth second in which we have to find out displacement. This is the displacement done in total n seconds, total time t. This is the displacement done in total time t, and this is the displacement done in the nth second. Okay. Then there are some types of graphs. Position time graph, displacement time graph, or position time graph. If graph is horizontal, that means position remains same with respect to time. Position remains same with respect to time. Position is constant, therefore velocity is 0. Velocity is 0, therefore acceleration is also 0. Therefore acceleration is also 0. Slope of xt graph is velocity. Slope of xt graph is velocity. For this graph is also x versus t. Graph is vertical means what? For this time there is no displacement. For this time there is no displacement. But suddenly at this time displacement becomes infinity. Displacement suddenly becomes infinity means velocity is infinity, acceleration is also infinity, and x is also infinity. X is also infinity. Then for third graph, displacement versus time. This is the straight line passing through the origin. Slope of straight line is always constant, and slope means velocity. Velocity means slope or derivative of displacement with respect to time, or derivative of displacement with respect to time. Slope is constant, therefore velocity is constant. Slope is positive, therefore velocity is also positive. Here x is increasing, and velocity constant means acceleration 0. Then this is third type of graph. Compared to slope at this point, slope at this point is more. Slope at point number 2 is more. More slope means at point number 2 more velocity. So in this graph velocity is increasing, which means acceleration is positive, and therefore displacement is also increasing. Displacement is increasing. This is the displacement versus time. Graph is going in upward direction, therefore displacement is increasing. Slope is increasing, therefore velocity is increasing, and velocity is increasing, therefore acceleration is positive. Then third type of graph. Compared to this point, at this point, compared to point number 2, at point number 1 slope is more. So velocity is decreasing. Decreasing velocity means acceleration negative. But graph is going in upward direction. Means displacement is increasing. Then this type of graph is coming in downward direction. Displacement versus time. Graph is coming in downward direction means displacement is decreasing. Velocity in this case is negative because slope is negative. Slope of horizontal line is 0. Slope of increasing line is positive. Slope of decreasing line is negative. Slope negative means velocity negative. And acceleration in this case is 0. Slope is constant continuously. Slope constant means velocity constant, therefore acceleration 0. Then velocity versus time graph. These are velocity versus time graphs. Area under velocity versus time graph is displacement. Area under area under velocity versus time graph is displacement, and slope of velocity versus time graph is acceleration. Slope is acceleration, and area is displacement. Remember this. What? Slope, slope is acceleration, and area is displacement. So in this graph, x displacement is increasing in this graph, and displacement is increasing because continuously area is increasing. For this point, this is the displacement. For this time, this is the displacement. So area under the curve is continuously increasing, therefore x increasing. Velocity is constant. Horizontal graph means velocity is constant, and acceleration is slope. Slope is 0, therefore acceleration is 0. Clear? Then second graph. This is also velocity versus time graph. Graph is exactly vertical. Therefore acceleration means what? Slope of the graph. Therefore acceleration is infinity. Velocity in this case is also infinity. Velocity is infinity, therefore displacement is also infinity. Then third graph. This is velocity versus time. Third graph is straight line passing through the origin. First one is displacement. For this time, this is the area. This is the displacement. For this time, this is the displacement. So as time increases, area under the curve increases. Therefore displacement is increasing. Graph is going upward, therefore velocity is increasing. And acceleration means what? Acceleration means slope. Slope is continuously same, therefore acceleration constant. Then in this case, area at T1 and area at T2. So area at T1 is this much, area at T2 is this much. So area is increasing, therefore x increasing. Graph is going in upward direction, therefore velocity increasing. Slope compared to at this point slope is more. More slope means more velocity at this point. Then for this graph, compared to this point, for this point more area, therefore x is increasing. Graph is going in upward direction, therefore velocity is increasing. Acceleration means slope. Compared to this point has less slope, therefore acceleration is decreasing. Therefore acceleration in this case is decreasing. For this case, acceleration is constant and positive. Displacement is increasing and velocity is also increasing. For motion under gravity, same equations of kinematics are useful. Only while substituting in the equation, we have to put signs. Acceleration due to gravity is always in downward direction, therefore we have to put minus 9.8 or minus g. For that, acceleration should be put as minus g. So if we put proper signs, motion under gravity is quite easy. We will see some examples of motion under gravity. See, the question is, a stone is dropped from the tower of height h. A stone is dropped from tower of height h. It touches the ground in 4 seconds. Then we have to find out height of the tower. Okay. So we'll consider this as the initial position, this as the final position, and we will use this relation, s is equal to ut plus half at square. So s displacement is in downward direction and that displacement is h. So we are putting, therefore we have to put with signs. If we are keeping s as it is, then no signs, but I am putting s as h, therefore I have to put sign. So displacement is in downward direction, therefore minus h. Object is dropped from this point, which means initial velocity is 0, therefore this becomes 0, plus half acceleration is minus g, and time required is 4 square. So minus h is equal to minus half gt square. So minus minus get cancelled. Half into g is 10 approximately, and time is 4. So this is 20 meter. Therefore height of the tower, 4 square is 16. So this is 80 meter. So height of the tower is 80 meter. Height of the tower is 80 meter. So what are the important points? While substituting, we substituted h as minus because displacement is in downward direction, and while substituting acceleration, we put acceleration as minus g because acceleration is also in downward direction, but time has no sign, therefore as it is 4 seconds, therefore t is equal to 4.